All right, I'm 10 minutes late starting the recording, guys. Apologize that for y'all watching the video. What we're talking about is what's known as a sentinel value. A sentinel value is a special value that is not a valid piece of data that tells the program that the user is done entering data. For example, enter a test score or negative Q to stop. Negative Q is the sentinel value. For a while, we had it as enter test score or -1 to stop. Hopefully you can't get a test score of a -1. So that served as our sentinel value. We had to make a couple of changes to make that work. So go ahead and pause the recording if you're going to enter this code and type it in and make sure it runs. And here's how it should run. Enter test score, right? We enter some scores, and then when we're finally tired of it, we type in a Q as requested and it stops. So Q is our sentinel value. All right. Pause. Get it in if you're going to do that. So to make it print a running tally so that we can see how large the number is getting, like it'd be a drag if you were playing football and you didn't know the score until the game was over. So let's copy this statement here and paste it here after we've calculated the new total, right? But before we ask them for the new value. All right. Total is 56, 156, 356. All right. Now we're good to go. I like this program. It's demonstrating a sentinel value. It's demonstrated a couple of techniques that we may not have used a lot yet, like the shortcut for getting the score and the input in one line rather than doing a print and then an input. And as a matter of fact, we could do the float at the same time. We could do float, parentheses, input, whatever, but then we would not be able to do this trick of checking to see if it's a letter. Because if we had done that, don't type this, I'm going to undo it immediately. If we had done that, it would immediately try to convert the score to a number. And that would blow up if they typed a Q, so we wouldn't be able to get to that line. And that's why I'm undoing that. One difference between doing a print statement and doing it as an input is that if we had done a print and then an input, it would be the cursor would be on the next line. And I know y'all have seen that already, right? You ask a question and the cursor's on the next line waiting for you to type. This way the cursor's on the same line. I kind of like it like that. All right, and I love this slide. It shows two examples. Both of them say, don't do it. And they don't show you the right way to do it. So we're not going to spend any time on that. So a text editor is used to create simple text files. Well, fundamentally, all programming editors are text editors, whether you're writing a complicated file or a simple one. An integrated development environment is one that gives you the editor and the programming tools right there. IDLE, ID, integrated development. I guess you could say that the L was maybe for language or something like that, but it is an integrated development environment because it's got the editor right there and you can run it right there. The command line is a location on your computer screen where you can type in entries to communicate with your system. For example, on Windows, if I hit the command key, which is the Windows, the flag between the control and the alt, and I hit R, and I hit those two things at the same time, it'll bring up this little run menu. Mac users won't see this. And there we go. Now we're at the command prompt. And you've probably seen me bop around here a little bit. The other way you can get to it is if you do that. Now you Mac users, if you want to interact with the command prompt, doesn't work for you. You Mac users, if you're going to work with the command prompt, there's a magnifying glass up in your menu bar, right? You go to the magnifying glass and click that and type in terminal. We're not going to do much in the command prompt because it differs dramatically on an operating system by operating system basis. The commands you type in on the Mac are completely different, but that's how you get to it. Go to the magnifying, click terminal. You should be able to launch it. Got it? Good deal, good deal. So type in ls with no spaces. And it lists all the files in that directory. Y'all won't be able to type in ls. ls is a Unix/Linux/Mac command. You would type in dir. So type in dir if you loaded up the command prompt. And that won't work for you, for the Macs. So there we go. You can see why I'm not going to spend a lot of time in the command prompt. Now, a graphical user interface is what we use every day. Instead of typing in text commands, like we were, old schooling it in the 60s, we're using windows and menus and stuff like that. However, all of our Python programs so far are command line programs, effectively, right? Even though we're not running it from that terminal or from the command prompt, right? I'm not doing that. I'm not seeing it there. It's still a text window, right? A scrolling window where I type text commands in. So the shell is also a command prompt. And I can even execute, commands here, but instead of communicating directly with the operating system, which is what the terminal and the command prompt do, instead we're operating with the language. And I'm not going to go over the evolution of programming models. Great thing to read. Alrighty. Why did we use a sentinel value? To test for infinite loops. Here's what the program, and don't make these changes please, would look like, or how it would act if we never offered them the option of quitting, right? I'm just going to delete that. Don't make this change. I'm going to undo it. Just going to delete that, and I'm going to run it. Enter test score. All right, now I'm getting tired. I want to stop. I have no clue. It's an infinite loop, effectively. There's a secret way to make it stop if I type in Q, right? Kind of a, what do they call them, Easter eggs or backdoors or something like that. But if I had coded it without that option, there'd be absolutely no way to get out of it. I would have to exit the program. I would have to kill the program in order to stop it. That's called an infinite loop. When you write a loop with no way out, this one does have a way out because it has a condition up at the top. And that condition is checked, and if this condition is ever false, it no longer executes the code inside, just like an if statement. If something, if blah blah blah, then do this, but if that blah 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 is false, it doesn't do this. While something, if that is false, then it doesn't do this, it stops. Alright, now I'm going to undo my changes. And we are going upward and onward to chapter 2. Oh, another thing I need to mention. I thought that I had already posted a link to this, but I did not. There are online versions of Python, so if your home computer doesn't support Python, I mean really they all do, but maybe there's a reason you can't install it, just type in online Python, and you'll get one at tutorials point. That's a perfectly good one. So I'm going to add that to our links over here. And then I happen to know of another one as well called Trinkets Online Python. Except I wanted Trinkets Online Python 3. So I'm making a link to that as well. Either one works great. If you get into a situation where you don't like the one that's working, you can use the other one. If you never use these, totally great, right? That's why you installed Python at home. Then why not use these always, right? I mean, why did we bother to install Python? Because this will not do turtle graphics. because you're likely to lose your program if you click the close box. Unlike idle, right? You click the close box on idle, at least your code is still there. You can go back and edit it. With these guys, that's not true. When you want to upload this stuff, you have to copy it and save it to the, to your personal disk and upload it. These are not nearly as convenient. But on the other hand, you don't have to install Python in order to use them. So your computer crashes, you're borrowing your wife's laptop or whatever, then you can do it that way.
Xcode's good for Mac.
Yeah, if Xcode supports Python, that's awesome. I haven't tried that yet.
I haven't.
That's cool. That's cool. All right, let's get our new PowerPoint. Anyways, you saw where I posted those. I went there under Table of Contents, Python. I've had some users in other classes tell me that they're not going to be able to install Python on their home machine, so you can do it that way. Elements of high-quality programs. We're going to learn about declaring and using variables and constants. We already know how to declare variables. Performing arithmetic. Kind of already know that too. Advantages of modularization. Now, I and Donna Wilson really hate the fact that this chapter gets into this early. This is a topic that we should be talking about like in chapter 4 or 5, not chapter 2. But here it is, so we're going to talk about it. Modularizing a program. Hierarchy charts, which I don't care that much about, but it's in the textbook, so we're going to cover it. And then features of good program design. Now, we already know how to declare and use a variable. For example, here's a variable. We declared it, right? We assigned a value to it. In this language, the act of assigning a value declares it. In other languages, that's not true. If we were doing C programming, and don't type this declares the variable. And you don't even have to put a value into it at that time. You could save that and do it later, right? So the declaration and the assignment of it are two different things in those languages. In this language, that's not true. You don't predefine your variables in order to use them. You just, boom, you give them a value and you're done. So that is an example of declaring a variable. You give it a name, and in this language, you give it a value. In other languages, those acts are separate. Then a constant. There are two kinds of constants. The ones that you really think of as being a constant are the ones that are given names. So I'm going to call that a named constant. Such as, now I'm just going to Google up some constants. What is the value of c? That's the speed of light. Alrighty. Do you have to type this? No. But c is equal to that. But I'm going to take out the commas. And to make it easier, I'm going to round it up. How many zeros do we have here? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make this 3.000 exponent 8. And I'm going to put a comment that this is the speed of light. Max scores, max score equals 100. The highest score the student can make, right? Things like that. These are named constants. Now, the reason we use named constants is to make the code easier to understand. If I have pages upon pages of code and I keep referring to 3.000 e to the 8, unless I'm a physics major, I may not know that that's the speed of light. Now, even c is not a great variable name because you have to be a physics major in order to know that that's the abbreviation for speed of light. So I might change that. I might say speed underscore of light to give it a good variable name. Now, c is certainly much more succinct, right? So I would kind of waffle between the two. But what if, I mean, you saw when I pasted it, there was a much more precise version of the speed of light, right? So what if later I want this program to be more precise? And what if I've used this number 70,000 times in my code? It's an exaggeration, but you get the idea, right? It's used 50 times in 50 different modules. And then, you know, it turns out that my Mars orbiter, slammed into the planet because I used the wrong value there. So next time we send it up, we want to be more precise. If I had hard coded this, meaning I literally typed it into the code rather than making it a constant, I'd have to go and change it to 50,000 times. I'd have to open the source code and make 50,000 changes in order to make that the more precise version. I could do that. I could do a search and replace. But what if at a certain point I made a typo? Right? What if 20 pages down I was calculating E is equal to M times, C squared, but I was a dummy and I typed in the wrong number there. There. E is equal to MC squared. I'm feeling real good about it, except that's the wrong value for C. And then later on, I'm using the right value. E is equal to M times 3.00. Or was it really to the 9? I've already forgotten. See, that's why you would use a constant. So there I use the right value. Right. I've just introduced a fairly difficult bug to fix in my code. Because I may not know. I may not realize that I've used the wrong value. Now that one's off by a factor of 10, right? It might be easy to spot. But what if I had made this 2 to the power of 8 here and 3 to, it's supposed to be a constant. It's a mathematical constant. It's a universal constant. It should not be changing halfway through. And by typing it in literally, making it an unnamed constant, a literal, I'm opening the door for errors. Whereas if I assign it once and then I use that variable name throughout my code, right? That's way better. If I need to correct it, I only need to correct it in one place. So I recommend using constants when appropriate. What's a good thing for a constant? Pi is a constant, right? How about the length and the width of a rectangle? I wouldn't make those constants, right? Because we may need to change the length and the width of the rectangle. Tax rate. Well, if you don't want the program to be changing the tax rate while running, you would define it as a constant. Now, in this language, there is no way of defining a constant. So why are we talking about it? Because there are other languages that do define constants. You could add the word constant in front of them. Don't. It doesn't work in this language. And that means that later on, if we go and type in our code and we try to change something else, change it to something else, it would flag that as a syntax error. You can't change a constant. It's already been defined as a constant. So, in order to indicate that we should treat this as a constant, even though there's no such thing in Python, we have a gentleman and gentlewoman's agreement, type it all in uppercase. And that means that it's supposed to be a constant, meaning that you, the programmer, should not change it later. Now, it's unlikely that I feel like I need to change the speed of light every time I hit across it. But maybe I think that, okay, I'm going to be writing a program where the max score of a test changes, right? The quizzes are worth 20 points apiece. The exam is worth 100 points apiece. And the homework assignments are worth 10 points apiece. Whatever, right? So maybe I'm under the assumption that I can change the max score on the fly, right? If I need to on a different place, I could change it to, 20. Great, except it may break other parts of the code that were depending upon that number to be 100. In the exam grading section, it has to be 100. In the quiz grading section, it needs to be a 20. But if it was set to 20 to do the other one, it would crash, or not crash, it would calculate the wrong answers. But we're smart. We know that if we have a variable in uppercase separated by underscores, that we are to treat it as a constant. It should only be defined once. It should never be reassigned. These numbers, like when we were down here and I had typed in, some number down here like 3 exponent 8, like that. This is what's known as a magic number. I see it in the code and I have no idea what it means. Maybe I know, maybe I don't, right? It's magic. I have no idea what it is, I'm doing some calculations like display is equal to, 40 times 1024 or something stupid, whatever, right? You have no idea what 40 means. and you have no idea what 1024 means. Or I'm going to change this like that, right? I have no idea what these means. These are magic numbers. It would be way better if I did this. And I shouldn't be doing uppercase D's. That violates my personal sense of what things look like. Equals, how about number of characters, and now this is kind of extreme typing, times character width. Right. And now I can, give that, our display's got 80 characters wide, and each character is 8 pixels wide, right? Now the code's starting to make a lot more sense, right? Rather than just doing display is equal to 80 times 8, because what if it changes? We make our font larger. We choose a larger font. We're going to need to make a larger display for that. So don't use magic numbers if you can avoid it. What is a magic number? It's just a number that arbitrarily appears in the code. It has meaning to you. On the other hand, if it's crystal clear what that number means, it's okay to use a magic number, right? Like the first element in a list is always 0. You don't have to create a variable called first element in list equals 0. Instead, you just put a 0 there. Or the formula, for calculating the circumference of a circle is 2 pi r. Well, that's just a formula. You don't have to make a whole new variable to hold that 2, right? You just put the number 2. But otherwise, if it's kind of inexplicable to somebody else who walks up why you put a number there, that's a magic number, and it should be in a named variable instead. Now that's philosophy. That's code's not going to break if I had made this display is equal to 80 times 8. But then if I needed to change it and I needed to recalculate it because they had typed in fewer characters or they selected a different font, that would be kind of dumb. So it's better to use the variable names to store that stuff. So understanding data types. Data dictates. Had we started chapter 2? Come on. I'm going to look at y'all too. Y'all are the front row people. Nope.
I don't think so.
Okay. When I teach multiple sections of a class, sometimes my brain gets blipped. All right, so I'm going to open up a section of notes here with triple quotes. Variables have 4 components. And I think I have said this. They have a name. They have a type. They have a value, and they have a memory address. We don't care about the memory address in this language. However, the name of it's crucial, right? You got to know what you called your variable. If you get the variable name wrong, it's a problem. Like if I type in width equals, 100 here, and then later on I say area is equal to width, it's an easy mistake to make. That's why I try to make all my variables start with a lowercase letter unless it's supposed to be a constant, in which case I use caps all the way across, because I don't want to make mistakes like this. It takes time to fix. If I use all lowercase, I'm better off. Anyways, so the name's important. The type's important. Why? Because type dictates 2 things. What kind of data can be stored in it, and what kind of operations. What operations may be performed on it. The book will word it a little bit differently, use slightly different words. For example, ints are whole numbers. You can do math on them. You can do addition, subtraction, division, multiplication, exponent, floor division, right? It supports all of those operators. Strings are a different beast. Strings are text. You can use plus sign to concatenate strings, and you can use multiplication to do multiple concats, but you can't do any of the others. We have talked about using plus sign to concatenate things. Yes? Nope. All right. Surprised if this is lecture E. If I go here into my Python shell and I type in first name equals Jeff. And then I type in last name equals first name plus quote space Thompson, end quote. And then I print out the last name, right? What did the plus sign do? It joined that piece of text to that piece of text. And now if we're going to get all Latin and special words for it, it concatenated that text, that string to that string. That's concatenation. Now what if we do something silly like this? Silly equals FN times 10. And I print out silly. Yeah. When have I used that? The only time I use that is to print out like a row of asterisks or something, like a row of dashes. Right? If I want, 50 dashes across my screen. Neat. So you can multiply a string by an integer and it creates a new string. That's this string repeated that many times. Right? This is this string repeated 10 times because I said FN times 10. But those are the only two operators I can do, right? I can't do x is equal to FN divided by 3. What would that mean, right? How am I going to divide my first name? Doesn't mean anything, right? Or x is equal to FN to the power 4. You can't raise a name to the power 4, right? So for strings, there's only two operators. There's the concatenate operator, and then there's the multiple concatenations, or the repeats. Never seen a good name for that one. So fess up, had I used the word concatenation before this class?
No.
Nope, okay. Then we better write a definition down. Concatenation, appending one string to another. And let's do that example. A is equal to, Donald, end quote, plus a space, inside quotes, plus Trump, plus quote Trump. Now when I print that out, it's going to say Donald Trump. Let's say that some of y'all don't like him much, and so I'm going to change that to Donald Duck. There we go. All right. If I printed A, it would print Donald Duck. This concatenates that string to that string to that string. Now, if we hadn't learned that fancy word, we would say that this is added to, right? But adding really means math. So the more technical term, the more correct term would be appending, right? We took this one, we appended that to it. We appended that to it. All right, let's play with a little of that in our code, if and we want to. So I'm going to make a string called FN for first name. I'm making it caps for some reason, and that's dumb, so I'm going to make it lowercase because it's not really a constant. People's names could change. First name is equal to, quote, Bob, end quote. Now I'm going to make a variable called greetings. Greetings is equal to hello. Comma. Space, end quote. Now I'm going to print that out as a message. So message, MSG, equals FN plus, quote, space, quote, plus, I've already messed this up. I'm going to delete everything. MSG equals greetings plus, quote, space, quote, plus FN. And then I'm going to print out F. I'm going to print out the message. So print message. And it blows up. Because I had this line in here and I told you that that was bad syntax and I didn't fix the code. And in fact, I just closed the file. If you ever close the file by mistake, just do File, Open Recent Files. Now I'm back in the saddle. I need to remove that word. Changing my little notes here. What is 80? What is 8? These are so-called magic numbers because it's not obvious what they are. I always recommend going back and rereading the notes like before the next class because I do clean them up and I add stuff on. I bet now that I've said that about 2 of y'all will actually do it, but it's not a bad idea to review your notes from the last class before attending the next one. Alrighty, so let's try it now. Maybe I've corrected all my syntax errors. And since I've written a program that requires input every single time I run it, I have to type in input, but I'm going to just put a Q right off the bat. Oh, for Pete's sake. All right. If you typed in these notes like I did, I don't care what M is. I'm going to comment that line out. I should have left all that in the green text, right? So that I wouldn't have to be correcting syntax errors in it, but on the other hand, it's good to get it exactly right. And there's our message, hello, Bob. That message was created by concatenation. Not an uncommon thing to do at all. Building display messages by taking multiple pieces of data. Very, very common, right? You're building somebody's address. You might print their street address, followed by their city, followed by their zip code, right? You may concatenate those 3 things together. Let's play with that. Street equals 123 South Main, end quote. City equals Midwest City. I don't know why I didn't capitalize South Main. I may fix that, make it a little bit prettier. The state equals, quote, okay, end quote. And the zip equals, I don't even know if we have a main street, I'm making this up, 73130, end quote. Now we're going to make a display string, a message that consists of all of that stuff. Oh, and look at that, the word zip is in purple, meaning it's not a good choice. I have no idea what the word zip means, but I'm going to change it so it's no longer purple. Whenever you're creating a variable and it shows up as purple or orange, fix it to something else. Even if it doesn't crash the program, it's not a good thing. And if it was an orange word, if it was a keyword, it would crash it. All right. As an exercise for y'all, create a message that equals the street, the city, the state, and the zip code all concatenated together. So go ahead and do that, right? To start here, message equals, and I'm going to wander around while y'all do that. Then I'll come back and show you the answer. All right, so I'm going to build a string here for display. So the message is equal to the street plus, now I'm making a mistake here if I do it like this, city plus the state plus the zip code. And then I'm going to print out the message. I've made a mistake. What's the mistake? Pardon?
No spaces.
Yeah, no spaces is going to look lousy. All right. Okay, yeah, there's a space because there was a space in our data there and there, but we want a space between the street name and the city name and the... So I need to go in and add spaces here. So where I had a plus sign, I'm going to make it plus, double quote, space, end quote, plus. The same thing here. Plus, double quote, space, double quote, plus, and plus, quote, space, quote, plus. And some people put a comma, right? Because that's, you know, Midwest City, comma, Oklahoma. That'd be okay, right? That'd make it look nice. I'm going to space this stuff out a little bit to make it easier to read. And then I'm going to show you a different way we could have done that. All right. This will be about the last thing we do for this class. We are going to end a little bit early today. I hope you don't feel cheated. Let me see the last homework assignment y'all got, though. Let me make sure. All right. Need to give y'all a homework assignment that I don't see there. So I'll discuss that in a minute. All right. I could have created the string like this. Message equals street. And then on the next line, message plus equals a double quote, space, double quote. Now this means append, concatenate the space to the message, and we're gonna have like 4 more repeats of that. As a matter of fact, I'm going to copy this line because I'm going to wind up typing that in 3 more times. I'm going to copy that line, or at least 2 more times. All right, and then message plus equals city, and then message plus equals space, and then message plus equals state, and then message plus equals space, and then message plus equals zip code. Message plus equals zip code. And then print the message out again. And it ought to look pretty much like your other one did. If you had commas and stuff up here, then you would want to put the commas and stuff exactly in the same. I'll bring the code back, don't worry. There we go, right? Work the same both ways. This is a series of concatenations. This is a single concatenation. One more thing I need to show you before I can talk about the homework. I really thought I'd assign this. Let me go check our homework folder over here. Nope. All right. So, I want to make a message that's like a Beatles song. So, I'm going to make this say song equals, quote, please nobody say, who are the Beatles? I'm kidding. All right. She loves you, backslash. The backslash is the one above the inner key. Yeah, backslash. Yeah, oh, and let me rewind all that. She loves you. It makes it a little bit easier to read if I put a space there. So backslash n, and then the word yeah, comma, backslash n, yeah, comma, backslash n, yeah, exclamation point, end quote. Then print the song. Now I created a string. It's actually got multiple lines in it because backslash n means go to the next line, like entering the inner key, on a typewriter. Carriage return, new line. Right? So print it out. She loves you. Yeah, 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 with each yeah on its own line. Each yeah is on its own line because it's preceded by the backslash n. There's another way to do that. Song 2 is equal to roses are red, end quote. And then song 2 equals, quote, backslash n, end quote. Except that should be plus equals. I'm so sorry, I made a mistake there. Song 2 plus equals, quote, backslash n. And then song 2 plus equals, quote, violets are blue, end quote. I'm getting tired of typing this backslash n, so I'm just going to copy that line and paste it. The next line of our song, song 2 plus equals, quote, some poems rhyme, And then the next line is going to say song2 plus equals \n. And then lastly, song2 plus equals, but this one doesn't. And then I'm going to print that song. I'm going to scroll this stuff up so it's kind of towards the top of the page. And it blew up. I made a mistake because I typed +2 instead, excuse me, plus at a certain point. So if you typed exactly what I did, it should be plus equals there on that line. All right, so I printed out a different song. Roses are red. Well, it's not much of a song. Roses are red, violets are blue. Some poems rhyme, but this one doesn't. Right? This is a multi-line statement, multi-line output created by \n. And by the way, I'll print this out for anybody who wants a copy of it, because the last few minutes of this are going to be rushed. And then this one uses concatenation to create it. Now we're going to do it one more way. Song 3 equals triple quotes. Quote, quote, quote. Oh, say, can you see? And on the next line, I'm just going to hit enter, not even going to close my quote. By the dawn's early light, and then end my quote. Or how about one more line? What so proudly we hailed. I'm going to stop there. And then I need triple quotes at the end of it. Quote, quote, quote. So I started it with triple quotes and I ended it with triple quotes. And then print song 3. Be right there. All right. So we've seen 3 ways of creating multiple lines of text. The first way was to use \n like that. The second way was to concatenate with plus signs or plus equals. The third way was to use a triple quote, which creates a multi-line like that. All right, so your homework. And then I'll come help, don't worry. Find some song lyric, poem, haiku, if you know what a haiku is, limerick. Don't make it an obscene one, please. I mean, it'd amuse me, but if somebody else saw it on my screen, they'd get offended. And print it out all 3 ways shown above. So you're going to print it out 3 times. Don't make it like more than 3 or 4 lines, right? When I say song lyric, you don't have to put all 7,000 lines of Eminem's Rap God, right? You know, just, I think I'm becoming a rap god, a rap god, a rap god. That'd be enough, right? Okay, so that's the homework for this. I'll create a Dropbox for it, etc. Does that make sense, guys? You've learned how to do it. I'll upload this example. Let's make a Dropbox so you can upload your stuff, and I'll walk around for a few minutes helping y'all before I run out.
Did you put your notes back on there?
I'll bring it back. Got to create the Dropbox first.
Oh, okay, sorry.
No problem. Normally I'm not this rushed for time, but I have to be exactly out of here by 3:15 thanks to my boss. Not that I'm complaining. I'm glad to have the job. However, the scheduling's frustrating. All right, there's a Dropbox E. Go ahead and upload into it whatever notes you want.